Um, we will talk about data quality and Spark, and also ways to have data quality and check for data quality without the cost, the usual cost of data quality. If you want to ask question, you can ask question during the talk. If it's a fit to answer this question right now, I will do it. Then if it's not, we will have more time to discuss about it later. Try to take a large chunk of time at the end to answer your question. So a bit about me. My name is Jonathan Winandy. I'm a functional programmer. Like I spend most my years in Scala, but I also do Clojure as well. And my day job is mainly to do data engineering in France, where I coach teams around data lakes. So I help a lot of teams in France to build better data platform in large corporation. I also co-founded and founded a couple of companies around data, predictive maintenance, healthcare solutions, and currently BI and so business intelligence and big data. So we will first talk a bit about data quality and do a short introduction to Spark, very short, and then present two solutions to improve a lot the data quality in pipelines, and also improve a lot the lead time of operation around pipeline. So how to have the same day delivery. I mean, like, can I push to production right away after coding my new feature? So why data quality? It's the thing is, its subject is a bit like not common because it's highly related to the data sources we collect. So everybody has data quality problems, but they are always different. So it depends of the kind of businesses you are in, the field you are, and the kind of tool you are using. And it's not a very common discussed topic because it's usually perceived as some kind of thing that is nice to have. But on quite the contrary, it's not very nice to have, it's mandatory because it slows down the project so much that some project may fail if they are not incorporating data quality at first. So it's a major concern nowadays in big data. So the thing with big data is, thanks to the democratization of distributed solution, we are now able to store a large quantity of data in the data lakes. So we can defer a bit the data quality concerns in the future. So we don't need to solve them now, but we still need to have some strategy because the problem is growing. So you don't need to solve it right away, but you still need to solve it to be able to provide data services in your organization. So there are two kinds of data qualities: the check and compliance and the anomaly detection. I will not talk about anomaly detection because it's highly domain specific, and we mostly talk about check and compliance. But once you implement the check and compliance part, you can run better anomaly detection because you have more features to detect on. So the impact of bad data quality is obviously it has a lot of impact in machine learning, because when you learn on average data and you run on bad data, you make bad prediction. But also it's bad for any kind of business intelligence activities, such as reporting, and it slows down the project. So some project might be stuck into this QA phase where you need to assess the quality of the project, but you cannot run the product in production because the numbers are not right. And you can be stuck in this phase for weeks or months. Like the code is done, but the data produced is not okay, so we are not able to deliver. And this affects a lot the team morale because you did your job, but because of something that doesn't concern you like directly, you are not able to ship, and you are not able to understand properly what's going on, and you don't have any kind of estimation when the data quality will be good enough to release the project. So it has a huge impact on the team morale. Also, I believe in same-day delivery. That's my closure side. Like when you actually change your program in memory and sorry. So when you change your program in memory and you deploy new feature on running instances, I really think that in 95% of the job we do, we could start something in the morning and ship it in the evening. And it's a bit challenging and it's a bit counterintuitive and running against a lot of the last known best practice. But this is something we can do thanks to distributed system and the fact that we can manage failure more easily than before. So this is doable, but the thing is that bad data gets in the way. Like you release something, but well, it's not good, and it doesn't depend on what you do. It depends on something else. So there are a couple of anti-patterns that can cripple you in this kind of undertaking. And one very common task in data quality is to check the aggregate. I've been in the like tens to maybe 100 of meetings where we are talking about the fact that the aggregates are okay or not so okay, and then we start the detective work, and this leads to waste of resources because there is no way to check anything based on aggregates. Like even if they would be the same, something underlying could be changing and have a huge impact on some other metrics. So any kind of data quality effort should be raw based and based on the smallest quantity of data, because it's what will be done if we are not able to find the root cause of the problem. So instead of trying to shortcut on the data quality efforts by checking aggregates and so on, and then maybe have some silent data bugs, we should always check for the conformance of rows, and it's better to do it like fully right away. It's maybe a lot of cost up front, but then it pays off easily. The other issue with data is this kind of topology. So this is common in data pipelines, and this is something that not a lot of people think this is an issue because they don't say it. But if there are some topology where the data have two ways to move in the pipeline. So there are two paths leading to the end result on certain data sets. And this is something that can be easily avoided, and this is something that decrease the performance of the pipeline, is usually related to the use of SQL, because SQL encourages kind of topology of jobs, and also it doesn't allow to centralize the checks of data, because like your data is divided into several paths, and depending of the path, you don't have the same rules concerning good and bad data, and then it creates a lot of problems. So this is one trick. Actually, I do a lot of audits of data platforms, and usually I go look for that, like the paths that are not trees, like that are real DAGs, like direct acyclic graph. And when there is two paths between the result and some of the sources, I know there is a problem there. It's very easy to check. Like there is always an issue in this kind of topology, and usually you can like make it pop, and then you have like some form of 10x to 20x of performance in the pipeline. So if you want to do data audit, this is a very good like pattern to look for. So based on those issue, I created Centrifuge, So it's an open source project, and the idea is to generalize a couple of techniques I've been using the past few years. And the main idea is to provide performance role-based analytics to allow to check volumes of data and as well to tag the data with data quality information. So let's talk a bit about Spark. So Spark is a generic cluster computing framework. And what's great about Spark is you have a coherent set of libraries that can work together to build pipelines running different kind of programming model. So you can start your pipeline with generic distributed computation, then switch to SQL, then switch to graph and go back to generic distributed computation. So you are always using the best tool for the job in Spark. Like, if you think about it that way, because you could do everything in SQL and then like try to push some of the computation in SQL, but what's good about it is you have the choice, and it is a very active community. So thanks to the Spark architecture, and the key component in Spark is a driver. The fact that your program is not run by something, it actually asks the master to run computation. So you have real program. For example, you can integrate the driver in reporting application, you can integrate the driver in long-running jobs and so on. You don't need to, you are not run into Spark like you would do in Pig or Hive or classical MapReduce. Actually, you control the cluster and you can run dynamic workload, as well as tuning the execution of your program after like collecting metrics and so on. So you have a lot of control and you are not locked to one level of abstraction. And we see why this is important, because Spark actually allows different ways to tackle the same problems, and we will see that with the two data quality solutions. So there is two main favors for distributed computation. There is the RDD, which is the historical one and still relevant if you want to do, for example, complex event processing. Like it's very good for that, or imperative programming on your data. And there is a SQL, and the SQL, like part of Spark, allow you to run very efficient job, because you define your job using SQL-like expressions, and then they are optimized to run on the cluster. So you manipulate some sort of intermediate language, and then it's run. So it's very efficient. But you cannot do whatever you want. So the RDD API is still useful. So let's introduce two ways of verifying data quality. The first way is to check volumes of data. So the problem is the following. It's like, I want to update my program that runs some data, but then I want to make sure that I did not break anything. So the classical way to do that is through unit tests. But the thing with unit tests, you are only checking some part of the behaviors, but you don't check the behaviors for real data, and especially what happened on the real data sets and the proportion that are out. Like for example, if you start to reject a row, did you reject too many rows or not, and so on and so on. The second way to integrate data quality is to use annotations. So with annotations, you can tag elements of data with data quality information. So let's check for the first one. So the idea is very simple. Is you have a function f that you map over your data, and you provide a new version of this function, and you want to make sure that this function behaves correctly. And it's not easy to do that, and I think it might be possible to compare two functions, but this is not the kind of problem I know how to solve. So maybe some people know how to solve this kind of problem. But the thing we can do is we can try to understand the behaviors of f with a sample of data, a sample of data of all the data that you have, depending of your computing capabilities at hand. So if you run the two functions and then you compare the result, you may understand something about the difference between f and f prime. But that's not very tractable anyway. So the idea of delta QA is to actually run the two functions side by side and then to compare the results. But it's not practical in real life because we are not able to replay the existing functions. Once you deploy a function, it's very difficult to keep it runnable because your environment may change, you may not manage your binaries properly. It requires a lot of infrastructure to be able to run an old version of the same program. So that infrastructure might cost a lot and might only be useful for this kind of experiment. So what can we do? And something that some teams do is to actually store the source data with the result of the transformation. And it's doable thanks to columnar formats. It's highly efficient, and it doesn't decrease on query performance. And by doing that, we are able to compare the result of f prime next to the result of f. The thing is, it's only the technical concern that are solved here, because we still need to define a function that can compare r and r prime, and to make this comparison in a way that can be aggregate after. So you could solve it like that, but it then requires like trained engineers to be able to define those comparison function and aggregation function. It's not that easy. So the way to solve that and to conform to real life problems is actually to project the dataset into a pseudo ring. So a pseudo ring is just a structure that defines a couple of operations like plus, minus, 0, and times. And then if you do that, you are able to compare your result. So you don't compare the result of the data, but you compare a projection of it, given that comparing the projection of it will give you enough information of the evolution of the underlying data. So this is one way to solve it, and also we use key and joins to be able to do it on real data sets, because real data set doesn't really store source data. Only a couple of data sets are using this kind of technique. So how does it work? Let's take a very simple table. So it has like 4 fields. So the ID, the name, the age, and the phone numbers, which is an array of phone numbers. And then we project this structure into a structure that has these pseudo ring properties. So the ID, the age, and the number of phone numbers the person have. Okay? Based on that, we can compare the previous and past results. So at the left, you have a certain data set with the same structure. At the right, you have the previous version of it after your transformation. And then you are able to join those two data sets based on key. And on each key, you're able to generate value depending of the nature of the join. So for example, if you have only one value on the left, you will put the value in certain columns. If you have one value only values on the right, you put the values in some other columns, and so on and so on. And when you have both values, you can compare them. So what happens when you compare them is you are able to have the difference. For example, on the line 1, there is so the number of phone is different. So you have one more phone number. The age is the same. And so the phone is different, it's over there. So it's here, the delta phone. And once you map all those joins results, you're able to sum them up column by column, and you get an aggregate view of what happened with your data. Okay? So it started as an implementation in Scala only. So there is a easy, I would say simple way to do it, but not easy way to do it in Scala is to use Shapeless, Spire, and Spark RDDs. And then it's better to use the data frame version because it's more performance and it's more coworker friendly. So the Spire version over there, it's 30 lines long, and it's very short, and it's relying heavily on type classes. So it's not very friendly, but you get everything out of it. It's like you do the join, and then for every type of join result, like you have the result on the left only, the result on the right only, on both, you are applying different operations. What? Okay. Please IntelliJ, what are you doing? Okay, thank you. So you apply different aggregation, and then you compare when you have two values, and you're able to generate this large row and to reduce it to a single row. So using like a monoid-like transformation and so on, like that everything is defined in Spire. So it works. It should work with no setups on generic structures, thanks to type class generation. I mean auto derivation. But it's not working right now because Spark is not able to serialize the structure right now. So we are using that on one data lake over a data set that have a couple of hundreds of fields, and it takes like 5 minutes to check the difference between two data sets. So it's a day of data. It's 100 gigabyte of data. It takes 5 minutes to check if anything meaningful changed. So based on so we implemented, so the projection is using like standard KPIs, like a number of clicks, number of visits, number of research per users, kind of like information like that you actually care about in business intelligence. So we use this same definition as the BI team, and we are able to tell them, well, with this new version of the program, we are sure to not change anything about the number of clicks, because we checked on every line for the past few days and it changed nothing. So it's not very practical to use, and RDDs and type safety are great when you know how to use them, and especially if you know a bit about Shapeless and type classes. So I did the data frame version as well. So this is the end result of the computation with the data frame version. You get for every metric that you define. So the first metric is just 1, like you put a 1 in every row, and then you have the number of rows. So you have 10 rows on the left that have not been matched by a row on the right, 5 rows on the right, and 100 rows that have corresponding values in both sides. And then you have these summed metrics for just left, just right, both, and then the delta between them, and then the number of rows that are actually identical for this metric. For example, that means that over 100 rows, 90 rows were having the age identical between left and right. So with this kind of view, you can easily find what's going on with your data. You see that one of your metric is off, and you can say, well, the variation is okay because it's increasing, so that means that it's better. or it's not okay. Then you can apply a business rule to every metric, but you are able to find the impact of the change of your function on every metric you define. And you're able to know how much did you lose, where is most of the row identical or not, because it's a very good property. Is like, let's say 99% of the row are identical, but only 1% of the row are different, and they are generating that much difference, and so on and so on. So to use that with data frame, you import the centrifuge. Yes? Well, on this version with the data frame, we use only dataset with numerical attributes for now. So to get the pseudo ring with the long is easy. So, but on the Spire version, is you have to make sure that there is a type class additive abelian group plus semi-monoid of multiply, something like that, like Inspire, on your class. But thanks to shapeless, it can be auto-derivated. So you don't have to do it yourself. But usually, like a case class, like a record with only longs, is a pseudo ring. Like you get a pseudo ring definition of it with every field. So with this version, you import the library, and then with two data frame with the same structure, you can generate this table by doing df1 dot delta with df2, and that's it. Your job is running and checking with the structure you defined before all of these metrics, and I think we can add more metrics, especially concerning the null values and the Boolean logic with nulls. So the data query roadmap is the following. So I want to add the partial support of all the types, Boolean, strings, and enums. I mean, partial support, just good enough to be useful. I mean, it won't be as complete as support for longs. To export the result to Excel, because Excel is great when you have to have like shiny colors in the cells and to really like expose the result. And also, I think it's possible to build an online query generator for other databases. So based on a schema, based on table with certain schema, we can generate the SQL queries for the databases as well. The problem is due to the structure of SQL, to have a meaningful result at the end, you will have to destroy the performance using a lot of unions. So I'm not sure it's possible, but is it very useful? I don't know. Okay, the second technique is annotations. So for annotation, the core idea is to use the standard way to do error processing in functional programming in the data environment. So in functional programming, when you want to manage errors, you have the validations or either monads, and you have the type result that is, for example, the either of error and t, or validation nil and t in Scala. So when you want to pass a row of data and you want to gather the error and not to use exception, for example, on the GVM, you will use the result line type, and it defines monadic operation as well as applicative operation. The problem in data processing is like we have non-blocking errors. So the types we use in functional programming are not enough. So we need to add warnings. So we get a type that is much more complicated. So we either return a value, t, or t with a couple of warnings, or an error with a couple of warnings. And so we have these three alternatives. The thing is, like in big data, there are actually close to 0 tools that support some types or co-products. So we need to encode that into a product type. So this is the way to encode that, is to have the value as a optional of t, and then to have the sequence of annotation, and the annotation to have a flag for errors. So this is one way to encode that. And then you have the applicative operation on it. So you can use it to create your structures, and so on and so on, if applicative are your thing. So who knows about applicative in the room? Applicative functors? So not much. It's very useful. It's key to understand fully like type functional programming, but it's very foreign. So it's not something you would go right away. So what we did is we defined a macro to replace the applicative and instead use generated functions. So for example, if you want to construct a person with values that are encapsulated in this validation scheme, you can use the build function and pass the fields, and then you get a person. And all the body of this function is generated by the compiler. So you can build your person nicely without the applicative syntax. It's a regular syntax. It's just your values are encapsulated in structures that encapsulate the validation. Okay. So what happens is once you do everything, like the annotations are rising to the root of the structure. So you are able to accumulate them at the top. So if we take the first line, we have John of age 5, and the age, like we see that the path is age, so it's generated by the macro to capture the path of the data. For the type name int is out of range. So the range might be like 13 to 110, something like that. And then you see that for this row, the age is invalid, so clearly out of range, like it's negative age. And also the name is empty, which should not happen. So you get for the same row a list of things that are wrong or that could be wrong. And thanks to columnar format again, we are able to store that and without impacting query performance. Because when you query your data normally, you will not read these values, so they don't get in the way. But when you want to analyze the quality of your data, you can do it, and you don't need to do joins, which actually slash down all the costs related to data quality. Because usually we do data quality after, and we need to rejoin the data with source data and so on. It is not the case. You have the tags on the same row as the values. So this method is satisfying. It's slow, but that's okay. We are running in your main ETL pipeline. Again, it's not coworker friendly. I think it's a great way to actually talk about Shapeless and Spire and Matryoshka and so on. It's great, but well, you need to do a step towards your coworker and make tools that they can use. And also, you cannot track the provenance of values. For example, you know that you have an impact on the output field, age, but you don't know, where this value is coming from. And that can be like hard to track. You need to go back to the source code to see, well, the field age is constructed with this data and so on. So I ported recently the annotation to data frame, so we don't have to use any kind of the applicative syntax and so on. So we use like normal SQL, and it increases also a lot of the performance. So let's take an example program. You would start your Spark program normally with a Spark session. You will define your your operation transformations, like to edge that takes an int and output a result of int. And you see that on certain values, like when it's okay, we just output the value. But when it's, for example, below 0 or under 13 or over a certain value, we also add annotations. And then we register this transformation, so thanks to the framework of Centrifuge. And we can run the query as if we were doing normal SQL and ask to include the annotation. So you could run your SQL query as if you don't care about data quality, and it will change nothing about what you did. But if you care about it and want to store data qualities on every row, you can include the annotation, and automatically that will collect all the annotation values to an annotation column. So the result is this one. So for example, like you get the age 12, it's under 13, you get the age -1, and it's below 0. So if it's below 0, it's an error. So it clears the data. It's set to null. Like it's better to have null than -1. So for free, by defining your transformation with a data quality component, you are able to collect all of it after query definition, and even through aggregation or through joins.
So Jonathan, it's 12. We can keep going for a few more minutes.
Yes, I'm finished actually.
What's that?
It's the last 2 slides. Okay. Okay, thank you. So the key lesson for the rewrite is like those tools were written first into these type say forms with shapeless, with applicative functors and so on. But then you can rewrite them to Spark SQL, and this is something great about Spark SQL. It's truly extensible. Like it's not something that the guys at Databricks said like Spark SQL will be extensible. It is. Like we are able to extend it. We are able to parse the query, to reinterpret them, to be based on their optimizer and so on, to extend it in a way that we can like inline data quality and have performant inlining. And also it's easier compared to Scala macros. So for those of you that do Scala and try to dive a bit into the macros, it's not that hard compared to Scala macros. And that's it. So do you have any questions? No question. You have one? Yes? No? Okay. Okay. Thanks. A bit the data quality concerns in the future. So we don't need to solve them now, but we still need to have some strategy because the problem is growing. So you don't need to solve it right away, but you still need to solve it to be able to provide data services in your organization. So there are 2 kinds of data qualities: the check and compliance and the anomaly detection. I will not talk about anomaly detection because it's highly domain specific, and we mostly talk about check and compliance. But once you implement the check and compliance part, you can run better anomaly detection because you have more features to detect on. So the impact of bad data quality is obviously it has a lot of impact in machine learning, because when you learn on subject is a bit like not common because it's highly related to the data sources we collect. So everybody has data quality problems, but they are always different. So it depends of the kind of businesses you are in, the field you are, and the kind of tool you are using. And it's not a very common discussed topic because it's usually perceived as some kind of thing that is nice to have, but on quite the contrary, it's not very nice to have, it's mandatory because it slows down the project so much that some project may fail if they are not incorporating data quality at first. So it's a major concern nowadays in big data. So the thing with big data is thanks to the democratization of distributed solution, we are now able to store a large quantity of data in the data lakes. So we can defend around data lakes. So I'll help a lot of teams in France to build better data platform in large corporation. I also co-founded and founded a couple of companies around data, predictive maintenance, healthcare solutions, and currently BI and so business intelligence and big data. So we will first talk a bit about data quality and do a short introduction to Spark, very short, and then present two solutions to improve a lot the data quality in pipelines and also improve a lot the lead time of operation around pipeline. So how to have the same day delivery. I mean, like, can I push to production right away after coding my new feature? So why data quality? It's the thing is it's on average data, and you run on bad data, you make bad prediction. But also it's bad for any kind of business intelligence activities such as reporting, and it slows down the project. So some project might be stuck into this QA phase where you need to assess the quality of the project, but you cannot run the project in production because the numbers are not right. And you can be stuck in this phase for weeks or months. Like the code is done, but the data produced is not okay, so we are not able to deliver. And this affects a lot the team morale because you did your job, but because of something that doesn't concern you like directly, you are not able to ship, and you are not able to understand properly what's going on, and you don't have any kind of estimation when the data quality will be good enough to release the project. So we will talk about data quality and Spark, and also ways to have data quality and check for data quality without the cost, the usual cost of data quality. If you want to ask question, you can ask question during the talk. If it's a fit to answer this question right now, I will do it. Then if it's not, we will have more time to discuss about it later. Try to take a large chunk of time at the end to answer your question. So a bit about me. My name is Jonathan Winandy. I'm a functional programmer. Like, I spend most my years in Scala, but I also do Clojure as well. And my day job is mainly to do data engineering in France, where I coach teams